Ladies and gentlemen, the Vice President and General Manager of Red Hat's Middleware Business Unit, Mr. Craig Muzilla.
Thank you, and welcome to JBoss World and Red Hat Summit. I hope that all of you who have attended JUDCon over the last couple days had a great event. But we're just beginning. We have a great event for the next several days. The theme of our show for JBoss World this year is JBoss Everywhere. And the concept is that, certainly there are major shifts taking place in the marketplace right now. Cloud computing is on everyone's mind. We're going to be talking a lot about cloud computing. But the idea is that middleware is still absolutely critical. And how middleware evolves and how it's being used is certainly going to change. So how you use it in an enterprise today will have to accommodate the needs for cloud computing, private or public, mobile-based applications. And we're going to show you over the next several days lots of technology and how the JBoss platform, we believe, and the entire portfolio is best suited for all of this activity. I'd like to talk a little bit about how JBoss has been doing over the last year since we last met. If you track Red Hat, we've been doing quite well over the past year. Our sales are doing great. The JBoss product line in particular is really moving well in the marketplace. What we're trying to establish, and our mission, is to provide a portfolio of products that help you, developers and organizations, build, deploy, as well as integrate applications. A couple measures of the success. One measure of success is how well do developers accept your technology, how much do they like the technology. And one measure of that, it's really a barometer, is the number of downloads that we have in our model, an open source model from our community, projects in the works. Over the past 5 years, the rate of downloads has been doubling every single year over the last five years, about 120% a year. We have cumulatively, well over 100 million downloads of JBoss projects. I mean, that's a sure indication that we're doing something right if developers are still very interested in the technology, if they're experimenting with it, if they're playing with it, and many of them are even contributing to the technology. Another measure is in how much the product and our technology is being used by organizations worldwide. We've run a lot of primary research, and there's been a number of independent studies that we've had nothing to do with that measure adoption. And well over 35% of companies worldwide are using JBoss someplace in their organization today. Another measure is our customer base. So just look at some of the largest companies in the US and in North America, the S&P 500. Over 35% of them are our customers paying us for subscriptions and taking their applications into production using JBoss technology. Why is this? I think it's part of, one of the reasons for this success is a strategy that we introduced 2 years ago. And it's all about choice. And you'll start to see a lot of the business units here at Red Hat talk about choice. And choice is very, very critical. So we introduced a strategy 2 years ago called JBoss Open Choice. And it's all about not trying to lock somebody into one programming approach, not locking them into a deployment approach, and giving them the most flexibility possible. So there's two principles behind JBoss Open Choice. The first principle is about the flexibility for the developer. So we support any programming model, a variety of frameworks, and a variety of languages, all within the same runtime environment. We're giving choice to the developer. So certainly, we're famous for our Java EE implementation. But we are the best place to run struts. We're the best place to run Spring. We're the best place to run Groovy, Ruby on Rails. And so we're really trying to provide a runtime that supports a variety of programming models. The second principle behind open choice is in deployment, the flexibility in deployment. So some of our competitors have pretty big monolithic stacks that come with a lot of stuff you don't need, that doesn't give you any flexibility. We know that companies today are looking for lightweight approaches, and they want to be able to select the services that they need based on the workloads at hand. So one of our philosophies in Open Choice is to give operations people, give developers the selection of what services they bring in, how they configure their deployments. And so we believe that Open Choice has helped us really move a lot in the marketplace. JBoss is a leader and an innovator. It's interesting, when you look at open source and the whole concept behind open source, I think there's a big misperception of open source. Some people think that, well, all open source does is it looks at existing technology and it does an open source implementation, an open source license, but it's really somebody else's thinking and somebody else's IP. Nothing could be further from the truth as it relates to JBoss. So we believe in standards, and we are still pushing very, very hard within the Java community. So if you look at our innovation, we've actually been one of the primary leaders in the JCP for the past 5 or 6 years. I don't think a lot of people know this, maybe not even in this room, but if you look, we've either been a spec lead or an expert working group member in over 35 JSRs. We were the leader in helping define EE5, EE6, and now EE7, which was just announced by the JCP a month ago. So if you look at some of the important JSRs, the most important JSRs, I believe, that have driven these releases, if you look at EJB 3.0, we took a significant role in that. We defined and wrote the specification for CDI. And just 2 weeks ago, we submitted a new specification, which is a JSR 347, which is for enterprise data grids, distributed caching technology. So we will continue to play a leadership role in the industry and continue to innovate. One of our goals, as I said, is to provide a platform for being able to build, deploy, and integrate applications. And so if you look just in 2006, all we had was an application server and a handful of developer frameworks. But if you fast forward today, we've built out and introduced 10 different products that allow you to do integration. So we have a SOA platform and an ESB, high-speed messaging. We have BPM and rules processing, and portal and user interaction, in addition to developer tools and management tools. So in this spirit of innovation, we made a number of announcements today. Our next release of our application platform is EAP, or JBoss Enterprise Application Platform 6.0, which is our Java EE6 implementation. We've announced our early access program to this technology. So you as a developer organization will be able to access this technology soon, and we will be shipping this later this year. The next announcement is a brand new product based on this specification that I just mentioned, JSR 347. So we just announced today JBoss Enterprise Data Grid, which is a distributed caching product. It's a data grid product. It allows you to establish an elastic, flexible data tier in your organization. This is one of the foundational technologies that we believe it will be very, very important for platform as a service and cloud computing in general. And the final announcement we made, we've had tremendous, you've seen the developer affinity that we've had, and it's just measured by the number of downloads. But we've had a tremendous demand for more education and credentials for developers. So we've introduced the JBoss Developer Certification Program today, which provides additional educational resources, but it allows the developers to earn a credential that gives them the expertise or proves that they have the expertise to help develop within the JBoss environment and help deploy JBoss as well. So in this spirit of innovation, we've got a great show over the next couple of days. I'd like to, in the next part of this presentation here, we're going to show you some great new technology, what we think is happening in the marketplace, and how JBoss will help execute against these changes. So to drive that, I'd like to introduce our head of engineering, Dr. Mark Little.
Thanks, Craig. So, as we just heard from Craig, we're doing really well. Since the JBoss acquisition by Red Hat, the number of platforms has grown from 1 to 8. Our number of projects on jboss.org has grown from between 16 and 20 originally to about 140 something now. The business is growing. We're capturing more and more mind share and users from the likes of Oracle and IBM. So, we could continue in that vein, and we certainly will continue in that vein. But is there more that we can do? Well, we think there is, and we think that we need to do it, not just for ourselves, but also to help to facilitate the development of ubiquitous computing. So hopefully most people in this room cannot fail to have noticed that things have kind of changed radically over the past decade, at least as far as hardware is concerned. There are already more mobile devices on the planet than there are computers. So really, ubiquitous computing is definitely here to stay, whether it's a processor in the latest SLR camera that you may have in your hand at this point, a smartphone, a Kindle, a pad, or even the latest engine management systems. There are, by some accounts, the equivalent of 20 years ago supercomputers or workstations sat in your pocket, or like I say, in your car. So really, ubiquitous computing is here to stay and has been around for quite a while. In the last year, since Apple created a completely new market with the iPad, they have sold over 20 million of these things. A recent, I think it was a Forrester report, predicted that by the end of 2011, 50% of Americans will have a smartphone of one form or another. That compares to only 10% in 2008. So, before I actually go on and tell you about how we think this impacts what we need to do as a leading open source company, let's look at what kind of has brought us here. And maybe, hopefully, apart from myself, some of the people in this audience will be able to look at this slide and recognize one or two of the devices that are on here. But, this is only 30 years ago. And these were devices that at the time were considered to be cutting edge and driven the new wave of personal computing. At the time, the very first Apple was just about to be released. Today, you would find it very, very difficult, if not impossible, to come across an engineer who would even consider writing a cutting-edge 3D game or a word processing package in 32K of memory. And yet, that device there, the BBC Model B computer, had 32K of memory, and those things existed on it. Today, we're kind of spoiled in a way. As I mentioned, if you look at these devices, we take for granted the fact that we have got really powerful devices on our laptops or in our hands. There are 4 times more processors of one form or another on the planet than there are people. So that's in excess of 28 billion processors. And that's processors in sensors, in RFID chips, in phones, in cameras, in coffee machines. And the interesting thing is that most of these today have TCP stacks. They understand TCP/IP. They understand UDP. You can communicate with them. One of the examples I like to give, which is probably slightly outdated now because I looked it up only about 2 years ago, is that there is a 16-bit microcontroller that can handle well over 16 concurrent sensor streams, is an eighth the size of a penny, costs significantly less than $1 to buy, so probably costs even less to make, and has more processing power in it than the VAX workstation I was using 20 years ago. So what does this mean for JBoss? Well, unfortunately, despite everything I've I've said, as an industry and to a degree as a user base, we still consider these things to be constrained devices. Think about the slide I put up 2 or 3 slides ago, the one that said 30 years ago. No, those were constrained devices. What we've got today are not constrained devices. It will not be long before you will have a washing machine or a coffee machine that has a processor in it that's more powerful than the laptop you were using 5 years ago, simply because of economics. More and more devices in the home or in the workplace are getting connected and or also getting connected not just with each other, but across the internet. Think about the Xbox or PlayStation Network or Wii. We take all these things for granted. So as I said, where does this leave JBoss and middleware? Well, we believe that whatever the deployment environment, whether it's a PlayStation, whether it's a server, and potentially whether it's a phone or a sensor, middleware of one form or another is needed. And if you look at what we were doing with those devices that I showed earlier, like the BBC or the ZX Spectrum, where 30 years ago when they first came out, we were using them to play games. The cutting-edge applications were word processors, and at that point, not even WYSIWYG word processors. Probably nobody, and I definitely count myself amongst this, but then I was a lot younger than I am today, could not think at the time of what we would be doing with these machines, how they would evolve over a 30-year period. But today, if you think about what we take for granted with laptops, never mind servers, they are the backbone of our everyday life. They are, in many ways, the nervous system of enterprise computing. What we do with them today is orders of magnitude more than what we ever thought we would do with them 30 years ago. And as a result, we believe that it is inevitable that the same thing will happen with pads, with phones. It's already happening with cloud, with ubiquitous computing in general. If you actually think about what's going on with near-field computing, if anybody's looked at that, there are Android phones, and I think, if not already, but very soon, the iPhone, where you will be able to swipe your phone past a sensor and purchase something without signing anything or typing in a PIN. You will be able to buy a book or a car. At that point, you better make sure that you have enterprise-grade middleware or some aspects of middleware on those devices, because you do not want a lack of security to allow somebody to capture that information. You do not want a crash in the 3G network to mean that your money got debited but your car was never delivered. If you look at what many development people are doing in the Android space as well, they are looking at reliable messaging solutions, or they're talking about the need for something that we would recognize as reliable messaging. And they want these on devices, on phones, on pads. So we are not going to tie the definition of middleware to a specific hardware or hardware setup, or certainly deployment environment. Certainly most of the people in this room will have come at middleware from the likes of mainframe systems and enterprise servers, but we believe that middleware transcends these environments. And before I move on, just another example of how things change. I have no idea if anybody in this room was involved with grid computing 10 plus years or so ago, but at that point, grid, which people today, to one degree or another, do point as a precursor to cloud, was the domain of academics and scientists and gamers. But today, if you fast forward and think about it as a precursor for cloud in one way or another, we are running enterprise apps on it. We require a lot more from our cloud than we ever envisaged we would if it had remained purely as a domain of academic institutions and certainly gamers. So at JBoss, we are going to enable these areas because We believe it's necessary for a number of reasons, but it's also necessary for the success of cloud. If you want to realize the benefits of cloud, where you pay for your cloud usage on per minute, per hour, or per day basis, you still want to make efficient use of the hardware that an Amazon or a Rackspace or whomever will give you. Yes, it can be cheap, or at least look cheap on paper, but if you have environments that mean you need to have a single hardware instance per application, then you're quite quickly going to rack up large bills, because Amazon will quite happily give you lots more and more hardware because that's how they're making money. What you want as a user is to be able to cram as many applications as possible onto the same physical hardware. So you want lightweight, embeddable solutions. And funnily enough, that's what you want when you look at phones and, and pads. So over the last 18 to 24 months, we have been spending a lot of time in various projects on improving our footprints, improving our performance, our embeddability, and also on simplifications to developer frameworks. We have wanted to make it really easy to develop enterprise applications. Complex applications should not need a PhD or rocket scientist to develop. So, as I said, we've spent a lot of time on this. Craig mentioned it before, but we pioneered the CDI work in E6. We're doing work on JPA and NoSQL. Hopefully people here, if they're into cloud, will know that NoSQL is one of the buzzwords around cloud at this point. And doing work in transactional memory on cloud again. And importantly, we are doing this through standards. Again, Craig mentioned this. Standards are important, very, very important for our customers. So where standards exist, we will adopt them. And where standards don't exist, and we believe there is sufficient experience to require a standard, then we will start driving them. And again, JSR 347 is a prime example of that. In many ways, we actually see what I'm outlining here as laying the foundation for, if you like, next generation cloud returning to ubiquitous computing, which again is another area that people say is an influence from 10 or 15 years ago when people were really talking about grid and ubiquitous computing. Ultimately, what we want to do is break down developer silos. We want to stop people thinking about middleware as only being relevant to enterprise servers and hardware. We want people to realize that things like Hornet Queue or JBoss transactions or REST Easy or TalkBox, they are projects, they are capabilities that can be relevant to a much wider range of environments. So we must make and are making our projects and platforms available to a much wider community. And I believe that we need to do this if the ubiquitous computing environments that I've been discussing are to actually be realized now rather than in 4 or 5 years' time. If you look at what happened with the likes of J2E taking over from Corba and Corba taking over from DC, and in the Microsoft environment, there's similar things with DCOM and .NET. It wasn't always the case that we were able to leverage the benefits of, for instance, Java immediately because we needed to reinvent the wheel a little bit. There were quite a few people who didn't believe that some of the things that had happened in Corba were actually pretty good. And I don't think we should have that with ubiquitous computing, or certainly what I'm discussing now, because otherwise, as I said, it could be several years before we can actually get to where we should be now. So enterprise requirements, as I've outlined, are pretty important. We believe that they are important outside of mainframe systems and outside of servers. So it doesn't really matter whether you're deploying onto clouds, onto mobile, or onto servers. At some point, for a certain class of applications, and hopefully the class of applications that are of interest to this audience, enterprise capabilities such as reliable message, such as security, such as transactions are necessary. And in fact, in some environments, they are even more necessary. For instance, in public cloud, security and fault tolerance are critical. So hopefully, many people in this audience will not fail to have noticed the Amazon outage that they had about a week ago. And another one that, if you're like me and you have a PlayStation, you may well have suffered from the Sony outage. I'm not going to delve into the problems that they had, but all I will say is maybe in one case if they had better security, and another if they had some level of fault tolerance, then the outages wouldn't necessarily have been complete, and a degraded service is a hell of a lot better than no service at all. So at JBoss, we believe in evolution rather than revolution. Unlike some vendors, we are not going to tell you that you have to throw out your existing infrastructural investments, whether that's hardware, software, or people. We actually like to think of this as, in a way, trying to make a new jigsaw out of existing pieces. We may need to develop a few new existing pieces. We may need to develop some new pieces or modify some existing pieces slightly for new capabilities, for instance, in cloud multi-tenancy. But ultimately, it should be possible to leverage a lot of what we have got, and as a community, a lot of what we have developed over the last decade or so. So, as I said, our aim is to provide our projects and platforms to a much wider deployment environment. And, I believe, and in JBoss we believe collectively that open source is the right solution for this. And surprise, surprise, we believe that JBoss is critical to this. Whether it's through the likes of the new modular services container that we've been working on for the past 12 to 18 months within AS7, or the work that Bill Burke and team have been doing on REST Easy, or Bob McWhirter and TalkBox and Hornet Q. All of these things can and should be made available to wider deployment environments, not just servers. These are all being developed with high availability, highly embeddable, and lightweight in mind. So let's kind of take a pause here, and as an industry, and certainly as JBoss, what we are doing now is, and have for the last year and a half, is stop designing just for today or yesterday and start designing for tomorrow so that we can leverage all the good stuff that's around. As I said, we've been doing that for a while, and you only have to look at quite a few of our projects that are out there, which include things like Arai, the Drools project, Netty, which Twitter is now using, JBoss Forge. A lot of projects have been taking this to heart and doing an absolutely fantastic job. And this, as Craig mentioned earlier, this is kind of what we mean by JBoss everywhere. JBoss not just on the enterprise server, but JBoss potentially on every processor in one way or another that you can think of. So now to this thought experiment. Let's kind of think about where we might be going with this over the next couple of years. And hopefully, if we all come back here in a couple of years' time, this won't be a thought experiment. Ultimately, what we would like to have, I think, is some kind of solution that can span a range of different deployments. Some kind of fabric, if you like, a runtime fabric, and maybe device-specific interfaces to it. It's all built on, again, I mentioned it just before, on the modular services container, because the modular services container, the kind of the successor to the JBoss micro container, has been developed from the ground up to be highly performant, highly embeddable, have a very SOA-like approach to services, and have a dynamic nature to it. So it makes a lot of sense for this to be the foundation on which we build. So this fabric, we could envisage where we develop, or somebody develops an application that is coded against this fictitious fabric at this point, and is deployed onto an app, onto an environment. And that environment is a phone or a pad, whether that's an iPad or an Android pad, doesn't really matter at this point. And the only projects that the application needs at this point are things like Hornet Queue, because it wants to do reliable messaging between the client and the apps that it may be using remotely. InfiniSpan, because we want to do large-scale data grid between lots of different devices, for instance. HTML5, because, well, it's HTML5. Drools, because maybe some apps on that, or some aspects of the app that we're developing wants to look through some data and do some business rules based on what it finds in the data. So all of these things are deployed locally onto the device. And if they can't be deployed locally onto the device, for instance, because the iPhone or the iPad doesn't support Java, then the fabric would dynamically configure itself so that they're deployed on some local, some service that is as close to the device as possible and interacted with through intelligent stubs. Then we deploy the app into an environment that is consisting of laptops or mainframes, and in which case maybe the app also increases in its requirements, and we get more to the traditional Java EE stack that we have today. And in fact, if you look at AS7, which will be the foundation of EAP6 later this year, you'll see that a lot of that is kind of captured in this diagram. We can dynamically add new components, transactions, JBPM, Seam/CDI, and they are all added on the fly by this fabric, and the developer hasn't had to do anything about this themselves. They haven't had to worry about this. Possibly the only difference, and I'll point out again, this is a thought experiment, so bear with me, is this kind of this social aspect. Everybody has an app store these days, so maybe we need to have an app store and consider what that would mean. As Java developers, we're used to maybe getting services and code through the likes of Maven or Gradle. But maybe in a few years' time, it may make more sense to get services or JBoss MSC services from an app store. Probably wouldn't be called an app store, but let's just call it that for now. And there may be a social aspect to this, where people can make recommendations, saying, I actually think this is a fantastic transaction service, or this is a much better messaging service than this. Ultimately, I think the human-based recommendation, the social aspect, if you like, only goes so far, because really what we would like to do is have this infrastructure monitored and managed and have that make recommendations based on metrics like reliability of components, performance of components, memory usage of components, make those recommendations in this store so that the fabric can select the right component based on those recommendations from the monitoring and management infrastructure. So now we go a little bit further and we deploy into the cloud, and because we're in the cloud, we have heterogeneous hardware and potentially heterogeneous software, and we need to add in an ESB. In this case, it's SwitchYard, so that we can bridge these different environments. And it's worth mentioning here that we would probably want to bring in SwitchYard anyway, because at least in our case, the ESB is an embodiment of a SOA infrastructure, and SOA is the right approach for developing applications in the cloud, because it encourages a separation of concerns and of loose coupling. And finally, I've hinted to this before when we talk about the social aspect, the only way in which this really can work well is if all of this happens, or majority of this happens autonomously. Again, another benefit of cloud is that you do not have to hire army loads of system administrators to manage your army loads of applications. You can have one or two people do it because the underlying infrastructure is autonomous. So in this case, our fabric would be monitored and managed by the likes of Jopper or John and Makara, which we acquired at the tail end of last year. So, ultimately, in a few years' time, maybe what we will have is a JBoss fabric that offers flexibility and reliability, security, all the things that you guys are taking for granted today on laptops and traditional JBoss environments, if you like, to a much wider deployment base. So I've mentioned quite a few projects, and platforms, CDI and Arai and the MSC, and I could drill down into those in more detail to kind of illustrate, again, some of the points that I've tried to make. But I actually think that actions speak louder than words. So what I'm going to do now is hand over to Burr Sutter, who's been working with the engineering team to develop a highly dynamic and highly interactive demonstration of quite a few of the points that I've just made. Burr?
All right, thank you, Mark. All right. Well, thank you guys very much. This will be an interesting several set of minutes for us because we're very much focused on demonstrating some of the key attributes you guys have heard about. So you heard about being easily embeddable, highly elastic, highly available, massively scalable, right? These are the attributes you hear about the cloud and, of course, the modern mobile movement. So we've created a demonstration, and we're going to show it to you live right here on stage. And so we're going to have a little fun with this. And we're going to need your participation as well, so keep that in mind. So right here, you can see up here on our screen, we have the red grid, all right? We're actually going to take a live Twitter stream into that grid. We're going to fill up an enterprise data grid, an InfiniSpan grid, all right? And we're going to hold all the data there. And then we're actually going to use Drools, all right, the JBoss BRMS, and we're going to analyze that data. We're going to do stream analysis, complex event processing. We're going to look at that huge data set, that massive data stream, and process it and move it to a second grid. And then we're going to have some activities on the second grid that are going to be very fun. All right, so our demonstration here today involves HTML5 for building rich user interfaces and specifically running those user interfaces on the desktop, which you'll see here in a moment, and also on mobile devices, which you'll see as well. We're going to use InfiniSpan. We don't want any data, right? Or excuse me, we don't want any databases. We have a NoSQL environment here. We're going to use InfiniSpan to keep all that memory, all that data in memory. We're going to use Hibernate OGM, Object Grid Mapper, a project you guys might not have heard of yet, but that allows me to address the data grid just as if it was a relational database. So we're going to interact with it through standard means in a standard enterprise Java way, but it's pretty much just Hibernate talking to the grid. We're also going to use Drools, we mentioned earlier. We also have CDI, context and dependency injection, JSR 299, and of course we run all this on JBoss, right? All right, so we have the reason we chose Twitter, a couple things that you should know about that. Twitter has over 75 million users. How many people in the audience use Twitter already, have a Twitter account? All right, excellent. We're going to need your participation, so keep that in mind. So 75 million users worldwide. They're growing at 500,000 users a day. All right, they process around, I think the last peak point was 140 million tweets per day. And they, at last one peak point, they had 7,000 tweets per second or transactions per second. So hopefully you guys recognize that as a large data stream, all right? So that was the easiest way for us to manufacture one. We just borrowed one. Another thing to think about with Twitter is it represents some things inside your typical enterprise. Right? If you're a retail organization, or let's say you work for an insurance company, or perhaps you actually work for a financial services company, you might have a ton of point-of-sale transactions that are occurring throughout your overall industry. Right? Think of your overall nervous system and all your IT infrastructure out there. If you have a ton of point-of-sale transactions, there might be specific events that you need to react to. You need to filter out that data and look for very specific actionable things to take advantage of. Perhaps you need to replenish stock, or you need to rebalance things within a warehouse, or you have to create orders that go out to your manufacturers. And if you're in a healthcare environment, perhaps, right, you have all these monitoring devices inside a healthcare institution that actually are creating events, producing logs, producing events that you might want to react to. So that's kind of the concept we wanted to show here in this presentation also. All right? So to help me do this presentation, we're going to invite some people up on stage. First one is going to be Manik Sirtani. All right, Manik, please come on up. He's our project lead for InfiniSpan.
Hello, Bert. How are you doing?
So can you give us a little background on what InfiniSpan is, more so than I just did?
Sure, absolutely. So InfiniSpan is the open source project behind the enterprise data grid product that Craig just mentioned and announced. InfiniSpan essentially represents itself as an in-memory data structure, a distributed data structure that is fault tolerant and gives you low latency, fast access to data. It's also elastic and it scales with scales out and scales back in on demand. People use InfiniSpan in a number of different ways. We see people using InfiniSpan to cluster their own applications. You can use InfiniSpan, you can delegate any state that you hold in your application to InfiniSpan. So InfiniSpan takes care of the elasticity and high availability aspects of your data, thereby leaving your application in a stateless manner so you can scale out very easily. People also use InfiniSpan as a distributed cache in front of a relational database. Relational databases are notorious as single points of failure. They're notorious as bottlenecks in high-volume environments and things like that. And using InfiniSpan as a distributed cache in front of a database helps alleviate these things. And further, we're also seeing people starting to use InfiniSpan as a NoSQL key-value data store, as an authoritative data source, which is cloud-friendly and elastic.
And surely no one's here had a crash in their database environment or anything like that, right? Everything stays up all the time, all your network interface cards. We've actually had some fail here on stage for us, just preparing for this demonstration. So we know things fail. So that's an incredibly important point. OK, so if you could, put up the demos for us here. All right. Let me make sure they're set. So what are we going to see here in these demonstrations? So what do we have visualized over here?
OK, so visualizing data is actually a really hard thing to do, right? I mean, bits and bytes, whether they're on disk or in memory, it's kind of hard to see them, to think about them in a visual manner. So we're going to try over here. What we've got here, this is a little web app here, and we've got the same web app running twice on the two different data grids. So you mentioned two grids. The first one where the Twitter stream comes into, that's this grid over here on your left. And this is the other grid, the second grid. Right now, there's only one node in there. Each of those spheres represents a node in the cluster. So as more nodes join, you'll see more spheres turn up. And what you're also going to see is the data itself. So as more and more data is loaded into the grid, we're going to visualize that as little dots around these spheres. Little dots, they're going to get bigger and bigger as more and more data is loaded. Now, what you're not going to see, though, is a mirror image of each other. These nodes aren't replicas of each other. We're running InfiniSpan here in a distributed fashion where enough copies of your entries are kept in the grid, but we only maintain as many copies as needed to be durable and fault tolerant. We don't maintain too many copies. So what that means is you're going to see little dots around these spheres, but they're going to be different numbers of dots in different individual nodes.
And what we have going on back here, we actually decided we didn't have enough capacity in this grid.
We've got a few more joining
so we
there.
threw a few more nodes in the grid. You can see they're dynamically adding themselves to the overall cluster. All right? So that gives us additional capacity. Think of all the additional heap spaces you now can take advantage of across those different JVMs. And you can see it animates nicely. Excellent. And this, it should be noted, so this is a little HTML5 application. I'll just refresh the browser. You can see it pops back into place. So let's go ahead and start up the Twitter stream, right? So we're going to fill this first grid full of all sorts of tweets coming into the system. And so this is our big grid here. If you could go and crank that up, there it is, starting to come into place.
So those little dots represent actual entries in the data grid.
Yeah, so every one of those little dots there, they represent a certain number of keys associated with each of those nodes. And you can see it's filling in very quickly as the inbound stream is coming in. And if you would, put laptop 2 up for me. So here we go. All right, so we actually have, so Manik, thank you very much. So we have the inbound Twitter stream. You can see here flowing into the system. I cannot be held responsible for anything you see here that's not appropriate for, well, this is an adult conference, right? So we're all good. We're all good. So you can also probably tell there's tons of teenage girls that love to tweet. Lots of Justin Bieber fans out there, I'm sure. So we have the Twitter stream flowing into the system. And the next person I'd like to invite up, all right, is JBoss. He's the project lead for our Rich Faces project. He's kind of our go-to guy for all things GUI here. So Jay, good to see you.
Hey, all right.
Excellent.
Good.
So you have a number of toys you left over on the table for us. What do you have here for us?
Well, we have a couple different things. We have a Motorola Zoom right here running the latest Android Honeycomb 3.0. We have an iPad 1, obviously from Apple, another iPad, iPad 2, and then a couple of different phone types here, an Android and an iPhone.
So, I've been checking out the Justin Bieber fans over here running on our user interface.
Right. Now, on this iPad, I've loaded up the same InfiniSpan view that you see over here. And this uses, all of these devices have different aspects of HTML5 support, such as the canvas tag, which allows us to free-form draw whatever images we want. In this case, we're using it to draw the data grid using jQuery JavaScript library, and then pulling that data from the JBoss application server.
And what's neat, you can actually see it pushed directly out. So as it matches directly with what you see over here on the projector.
Yep.
So HTML5 canvas, we basically are taking advantage of HTML5 to live monitor an enterprise data grid filling with data on a mobile device. So very cool, very cool. Thank you very much for that, Jay. And what else have you got for us over here? You got some other toys?
Yep. So as I said earlier, I have a Zoom here running Android, and it's running the exact same application that you see here. This is a Rich Faces 4.0 application written with JSF2, and we've written it in such a way that it can support different device formats and different styles. So in this case, we're running it on a tablet device, so we have to use advanced HTML5 and CSS3 to support things such as orientation shifts. So you see here where the top tweeters and top tags kind of flow as you change the screen. They're always visible because that's the data that's important to you, right? So we use that to our advantage to keep the data clear. Now we also support the Yes, the password will be changed now. Thank you, everybody. Appreciate that. So we actually we support the iPhone version as well, which of course is not going to load right now, following typical demo gods.
Okay. Well, but that's excellent. We actually saw the device orientation change. We have Rich Faces 4 also pushing data out to a desktop-based application.
Yep.
Same code base working on a mobile device, including a pad as well as a phone. And maybe you'll get that working before we're done. So there's a couple of things I want to show you. So at this point, we do need your participation, all right? So you guys all have phones, and you guys all have tablet devices. How many people actually here have more than one phone or more and one device? Because you probably have several. This is a software conference. Be proud of that, all right? You got multiple in there. So what I need you to do, and I'm going to just switch pages here and show you guys this, all right? I need you guys to tweet. At this point, we're going to specifically drive data into the overall Twitter stream. We're capturing all those tweets that are flowing into our system to fill up our data grid over there. And we need you guys to tweet with this format. So you guys have a Twitter account. You got to break out your phone and basically say #JBW, #app server. We know that many of you guys use the app server today, right? We know that many of you guys use Hibernate today. Maybe you take advantage of JBPM. Maybe you take advantage of Drools. Maybe you take advantage of Tiet or Governor or Snowdrop. Who knows what project you guys take advantage of? You can all vote multiple times. So really, look, you get out your phone. Really, this is where you get to do it. You get to have some fun. We actually have a prize for the top tweeter who tweets the most during our demonstration today. And it's a very cool prize. You don't want to miss out for it. As a matter of fact, I'll tell you, we're going to actually give away one of our data grid nodes. All right? So we're going to give away one of the nodes you see over here in the data grid. So go ahead and get those tweets flowing into the system. Jay, you're doing some tweeting for us here?
Oh, yeah.
All right, so his phone's working? All right, very good. And again, the format is #JBW, #app server. You know, whatever you want to say is awesome, is cool. Say something nice. Come on. It's our conference. And #JBoss. It doesn't require the JBoss. And again, think of the use cases for this sort of technology. We're specifically showing you, again, a flood of data, raw data that has nothing to do with our business per se. And we're going to sift through it, basically using Drools Fusion technology. And many of the Drools team is here today. They can tell you more about this technology. But it does real-time event processing, real-time stream analysis. And it's specifically going to start up, and if you would, go ahead and start up the rules so we can kind of see the data start flowing into our second grid. Okay? Again, we're looking for actionable data that's specific to the use case that we have, and then we can have a real-time dashboard. And as a matter of fact, bring up my laptop 2 here if you don't mind. And so we've got that cranking now. Okay? You can kind of see, here's an example, another user interface we created, highly interactive. You can see our data grid filling in over there as well. So you can see App Server is winning this race right now, and Finispan's doing pretty well, Archillion. Well, and Jay, do you have this on your mobile device as well?
Yep. Over here on the iPad 2, we're running the Tag Cloud application. This is a GWT application that was written using the JBoss Array project, which provides an advanced message bus so that you can use CDI and SEAM programming models all the way through to the client on a GWT application while still communicating to the back-end application server.
So this is really cool. We've showed you 3 different user interface technologies, one based on GWT and Array doing real-time push of CDI eventing directly from the server right out to the client, both a mobile client as well as a desktop client. Again, taking advantage of that new mobile technology. We also have the JSF2 and Rich Faces 4 part of the application pushing out votes. And you can see, you can kind of see right here, right? App Server's doing very well.
Yep.
And so actually keep it focused here on what Jay's tablet's doing right here, because we want to be able to see who's winning right now. Notice, right now we have Finispan's done very well, which is great. They're part of the demonstration. SEAM, Archillion.
Oh.
What? Mark Proctor. We have Mark Proctor going up to 35 top tweets.
40.
And 40 tweets. Let me look on my console over here. Okay, well, I messed that up. All right, so so what happens here?
He's got
Mark,
55 tweets in at the moment.
Where's Mark Proctor? So Mark Proctor, obviously, you wrote a script to game our system here, didn't you? Okay. So he's jamming. He's got 64 tweets into the system. Okay. All right, so here's what we're going to do. All right, so Drools might be the winner after all, but we want it to be a fair race. Several of you guys voted multiple times. We've collected all that data into our first data grid. We all have it there. We're going to keep that raw data in place, but let's go ahead and clear out the second data grid. Okay, reset it back to its original state. And then what we're going to do is now we're going to process those tweets yet again and restart the rules. So what we're going to do is change the rules to defeat rules. Defeat Mark Proctor in his little cheating experiment over here, all right? Because we can actually change the rules so it says, the rules right now basically say, hey, if everybody votes for a specific project, right, move that project over into the second data grid. We'll change the rules, and Sonny's already reset the rules for us. Now it's going to look at the sliding time windows, right? So in other words, as the stream is moving forward, you can vote multiple times for multiple projects, but you can't vote for the same project multiple times within a 3-minute window. So that'll eliminate you guys. Some of you guys are probably writing scripts as well, aren't you? All right? So that should drop that out. What kind of results do we have now?
Now it looks like App Server's in the lead.
App Server's in the lead. A lot of App Server fans in the audience. You guys, yay. You like the App Server? Say yeah. All right, very good. App Server's in the lead. What else we got?
Well, it looks like
and Finispan's doing well. They're part of the demo. Excellent.
Finispan's right there. TorqueBox, SEAM. Oh, SEAM just took over TorqueBox.
Uh-oh. Okay. So it looks like we have Pearl Monkey as our top tweeter, right? Excellent. So Pearl Monkey, why don't you come on down here? Who are you? Pearl Monkey. Excellent. Here he is. Excellent work. We have a microphone. So is Pearl Monkey your real name?
No.
No? Please turn around. Let everybody see you. What is your name, sir?
Sean Cook.
Shanka? Well, it's nice meeting you. You must have incredibly fast thumbs.
Cut and paste.
Cut and paste. Not quite a script, but yeah, pretty close.
When you guys get JBoss running on this, and I can actually do something that
we almost did that as part of the demonstration, was actually let you run those UIs, but we decided we didn't have time to get the network sorted out. But excellent. So you won our presentation today, so thank you very much for your participation, and thank all of you guys for your participation. So Manik, can you come up here and give me a hand? So you notice I told you you're going to get one of our nodes from our data grid.
Sweet.
Right? So what we didn't tell you exactly was you probably thought all this was part of our data grid. Literally, this is just here for show and tell. All right? We mentioned the concepts of being lightweight. We're really focused on being lightweight, and one of the reasons that's important is if you're starting 5 servers and they take 45 seconds each and take a gigabyte of RAM each, yeah, that's no problem. If you're starting 500 servers, specifically in a fabric or a cloud architecture or a grid architecture, and they take 45 seconds each and a gig each, that's going to be very painful. All right, that takes too long and it's too fat. In this case, we actually have these little guys right here. If you help me, there we go. Thank you, Manik.
This is our data grid.
This is our data grid running right here. You guys can see them on the big screen. These little guys right here. So these are our little Linux servers, right? They are a Linux server with a 1 gigahertz processor running an ARM gigahertz processor, 512 megs of RAM,
Your
right?
phone's more powerful than that.
Does it come with a subscription to John?
We might throw anything in, you never know. So our data grid here is running on these CPUs, these little computers right here, these little plug computers. And so that's pretty amazing by itself. But we talked about the fact that fault tolerance is important. And this is where we get pretty crazy in the overall demo. We're going to let you pull the plug.
Let's simulate a network failure.
Right?
Pick a node.
Pick a node, any
So
node?
pick a node. We're going to jerk the network cable out of it.
How about this one?
All right, this one right here. All right, feel free to pull it out of there.
No, not that one.
Yep. And if you watch closely, watch your overall grid. It takes a few seconds for InfiniSpan to realize that we have lost one of our members, and it'll disappear, and the grid reforms perfectly healthy. So, sir, we're going to get you the cables and all that later, but you're going to come back and pick this up. So thank you very much for being a participant.
Thank you.
Thank you.
Thank you.
And Jay, all our stuff stayed up. All our clouds are still running here, our Tag Cloud, our Tweet Stream.
Everything's still running. Everything's still pushing.
So from a user standpoint, it all stays up and running. App Server stayed in first place. Drools did incredibly well, though, after all. So thank you very much for that. Again, thank you, Jay. Thank you, Manik. And back to Mark.
Thanks, Burr. And we had absolute confidence that was going to work. Yes, we haven't been here for the last 48 hours making damn certain it works. So, in conclusion, I mean, as I said, actions speak louder than the words, and a lot of what we've just seen demoed here, whether it's the HTML5 GUI that Jay was illustrating, or the little plug computers, are examples of things I was talking about earlier. We're going to see cloud continuing to grow, but we really do believe that the definition of cloud needs to evolve and will evolve and go back in some ways to ubiquitous computing. And enterprise middleware remains important across these new deployment environments. And we will be there. Our projects will be there. Our platforms will be there. And in some respects, we are already there now. Like I said, we are better for the enterprise, ready for the cloud. That's the byline. Really, it could be better for the enterprise, ready for the cloud, and ready for ubiquitous computing. JBoss everywhere is the tag, and it really does mean exactly that. You should expect to find JBoss technologies wherever you need them, whatever the size or capability of the device, whether it's a small sensor, a plug computer, or a large mainframe. So with that, I just want to say thank you all for coming. Thank you all for spending the time on interacting with our demo. Have a great event. A lot of the things that we've talked about here, you will be able to see presentations on. The engineers who are involved in it will be around for the next few days. Grab them if you want. We will be making this code available as well in open source, so you can play with it. And at some point after this event, we're also going to have a series of discussions going in more depth about what really happened in the demo. One last thing, check out our booth and the JBoss party, which is coming up. And if you go to the party, it is an open bar, and you will find, I have been told reliably, that there are cocktails that are named after all of our platforms and possibly some of our projects. I have no idea what's in those cocktails, but I do intend to find out. So thank you all very much, and enjoy JBoss World.